Hi, my name is Aaron Pappy, and this is my data analysis of the airline dataset. Airlines across the United States are responsible for transporting millions of people across the entire globe each year. While airplanes have been one of the greatest inventions in the past century, they have also experienced their fair share of problems. Delays and cancellations of airline flights happen every day across the country. Abstracting is the process of turning real-world entities and phenomena into data. In this project, I abstracted airline data into reports. Each report has a number of properties related to my project. Airports. This is a list that represents the location and code of airports in the USA. Carrier. This is a list that represents the airlines that fly out of these airports. Delays. These are dictionaries that represent the minutes delayed and the numbers of delays and why they occurred. The representation on the right is the full structure of the abstracted dataset. Weather. This is a key that represents either the minutes delayed or the number of delays that occurred due to inclement weather. This value is an integer. Carrier. This is a key that represents a dictionary that has a list of names of all the carriers that fly out of airports represented in the dataset. For example, there are carriers such as United Airlines and Delta Airlines. Airports. The key represents a dictionary that contains a list of airport names and codes. For example, Dulles International Airport is represented as a name, and the code is IAD. Some of the limitations with this dataset include you cannot go deeper into the weather side of delays to just focus on strictly one certain storm system. Another limitation is that you cannot dissect what kind of engine failures or mechanical failures that cause planes to delay and cancel. And probably the biggest limitation is you cannot pull the minutes delayed for a whole year and graph it because the dataset only breaks it down monthly. My first question was, do the minutes delayed totals at Los Angeles International Airport and Denver International Airport in the year 2015 share any similarities, or is the data just random? Based on the visualization, the graph for the most part move in a very similar fashion, which would point to the fact that airports delay and cancel flights pretty similarly. However, in the winter months, you can see that Denver International Airport experiences a lot more delays, which may be due to the fact that Denver experiences a lot of inclement weather in those months because they are located in the mountains, which is where they get their nickname, the Mile High City. Also, what is interesting to look at is the fact that both of these airports peak delays in May and June. This can likely be attributed to the fact that planes malfunction more in warmer weather and that these are two of the months with the most travel, so there's a ton of air traffic that can also cause delays. Question 2. What caused the most delays at John F. Kennedy International Airport in 2015? If you do not know, John F. Kennedy International Airport is located in New York. Based on the visualization to the right, John F. Kennedy International Airport, or JFK, easily has the most of their delays due to the National Aviation System. A delay by the National Aviation System can pertain to almost anything, from a crowded airspace to a non-threatening weather storm. Security and weather were both surprisingly low compared to the other three. I would have assumed in a place like New York there would be a lot more security and weather delays due to the fact that New York is a very crowded area and weather in the Northeast is very poor at times. The data is actually really interesting because you would assume that the National Aviation System delays would peak in the summer because that is when most people travel. But it is actually in February, which may mean that there are more NAS delays for minor weather conditions rather than crowded airspace and other space constraints like that. Question 3. What is the correlation in the amount of minutes delayed and the total amount of carriers in each airport in November of 2015? This visualization shows that while there is a little correlation between the amount of carriers in an airport versus the number of minutes delayed during the same period of time, while the airports with the most minutes delayed also had the most carriers, you can see that there are airports with less carriers with a lot more minutes delayed. This was kind of surprising to me, as I assumed that if there are more carriers in your airport, then there would be more delays due to the fact that higher amount of planes would be flying out of your airport. It's funny that there is an airport that had only 4 carriers that had more delay minutes than an airport with 11. Social impact. Various stakeholders would be interested in the analysis of this data. Some of them include people who have to travel for business. For these people, they need to know how to book flights and ways of getting out of and around delays in order to get to their destination on time for their meeting or any other work they have to do. Airport carriers use this data to see not only where they struggle, but they can also use this data to track their improvement over time. Vacationers. People who are looking to get away for a week or two will use this data to plan their flights out in order to maybe avoid the last-second delay and get on with their rest and relaxation. Potential conflicts between stakeholders may include vacationers complaining about lack of improvement by carriers in the airport in getting the delays in control. Traveling businessmen have to miss big meetings because airports overflowing or a lack of preparedness by the carrier. As a Hokie, I do not accept the acts of lying, cheating, or stealing, nor do I accept the action of those who do so.